Okay, so what we're going to talk about section 7.1, which you can see on the screen, is systems of equations. Again, probably review for most of you. So if I'm making an assumption though, if I'm going too quick, never be afraid to stop me. But I also don't want to bore you to death with something that you've seen. So we're just going to practice our ability to solve systems. And then in section 7.2, we'll elaborate on systems, probably do something you haven't seen before. And then we'll continue going. So there's 4 sections in this final unit. So my first example is just to remind us what we're doing when we solve a system of equations. So what we're going to do in this first section right here is we are going we're gonna learn or remind ourselves of a couple different ways to solve systems. So here I've got 2 lines. And below, you'll see the equations of different lines. When I solve a system, okay, when I want to know what point is the solution to this system, where do I look on this graph? What represents the solution? Yeah, the point of intersection. When we solve a system, what we're doing is we're saying, where do these 2 graphs meet? Okay, so when I ask you, and I will on the test that you have on this last unit, to solve a system just by looking at the graph, what is the solution to the following system of equations? We just go ahead and we look at this point of intersection that is right here, and that is at the point -2, 1. I'm going to put it in I'm going to put it in parentheses, but then just so that we don't get confused with our interval notation, because that looks like the interval from -2 to 1, what I'm going to do is I'm going to put it in some squigglies so that we know that that is a solution set. So solving a system is finding where the lines or whatever the figures are, where they intersect. So just real quick, I'm going to give you 24 seconds. Go ahead and do exercise 1. What's the solution of that system? Okay, what did you write down as the solution to the second system? Yeah, it's the x value is 3, the y value is 4. I'm going to put it in some squigglies here so that we know that the solution's set. Anybody have a problem identifying the solution? It's something we've done before. We've in fact been looking at graphs and looking where things intersect and where they're bigger than 0 and less than 0. We've been doing that all semester. So that is not a skill that is any different. So there are 2 primary methods to solve systems. And so we're going to review these methods with linear systems, meaning lines. The first is the method of substitution. Okay, so that's how we're going to solve these first, the method of substitution. Now, anybody, can you remind me, what is the premise? What do I want to do when I solve a system by substitution? I'm sorry? That's going to be the next one. That's going to be elimination. So you're a step ahead. Yeah, go ahead. That would be something you would do for more complicated systems that don't have easy ways to solve. That's a great thought. You would make up a solution for the first equation, and then you would see how it works and what adjustments you have to make. What we're going to do for substitution, then, just to refresh all of our memories, is you solve for one of the variables in one of the equations. Okay, so the key to substitution, excuse me, especially with linear systems, is you solve for a variable that can be done easily. Meaning, oh, sorry, I'm off the screen. We're going to solve for a variable that can be done easily. Meaning, I want to avoid fractions. I don't want to make this harder on myself than I have to. Okay, so I'm going to pick one of the variables that is easy to solve for. Now, in this example that I have, there is one variable that's really super easy to solve for. There's another one that would be okay to solve for. Which variable is the easiest one to solve for in this system? Which y? Yeah, the one on the bottom. And the reason that we're saying that is because there's no division involved. It's one step. I just got to add that x to the other side, and then I have that solved for y. So what we're going to do is we're going to solve for the y that I've put the arrow underneath. And I'm going to do that by adding the x to both sides. I don't think this is too much of a challenge. You all are in college algebra. We're almost done with it. So you've messed around with equations. So what we end up with is y is equal to x plus 3, or 3 plus x. The order is not particularly important. Everybody tracking with me? We're doing okay. Let me know if I lose you. Hopefully this is flooding you with amazing intermediate algebra memories. Then what we do with that now is we're going to take this equation, which says y is equal to x plus 3, and I'm going to plug it in for the y in the other equation. So what I'm going to do is I'm going to plug what I just have now in for y in the top equation. So that top equation is 3x plus 2 times y. Now, I've done this before, so I'm being consistent. Instead of plugging in right away, I'm just going to put a parenthesis here. That's blank. That parenthesis represents the y. And then that's equal to 11. And then what I'm going to do is I'm going to take the y value that we just got from the second equation. Y equals x plus 3. And I'm going to put x plus 3 right here. We okay? All right. So now this we could all do in our sleep, I'm pretty sure. I'm going to go ahead and distribute. I'm going to collect those like terms. I'm also going to subtract the 6 from both sides. And so when I do that, 3x plus 2x, that is 5x. I'm going to bring it over here. And then 11 minus 6 is 5. And when I divide both sides by 5, I'm writing out all the steps on this first one just so I don't lose anybody. X is 1. So there's half my answer. And then inform me, how do I find the other half of the answer? Yeah, you substitute back. And again, you can use either equation, but we've already gone through the effort to make this equation say y equals x plus 3. So I'm just going to go ahead and use this one right here. Y is equal to 1 plus 3, and that means the y value that goes along with it is 4. We always write our answers as an ordered pair. That this will be a mild deduction on the test. So please just make sure you're using your right notation. So the x value is 1, the y value is 4. I'm going to put it in some squigglies because that is my solution set. If you have any question, comment, or concern, please bring it up. If not, I would like you to go ahead and do exercise 2, the one right next door. We're going to do this by substitution. The reason I'm reminding you of substitution, by the way, is we are going to do some nonlinear systems on the second page of this. And nonlinear systems for our work is going to be best done with substitution. Okay, linear systems, as was mentioned by somebody else, linear systems, I think, are easiest solved when you cancel something like we're going to do in the next example. All right, so exercise 2, there is one variable that is going to be the easiest one to solve for. Let's all identify it so we're all doing the same thing. Which one is the easiest variable to solve for? Which y? Perfect, excellent. The y in the top equation. So solve that equation for y and then do the substitution. Give about another minute to make as much progress as you can. Okay, so what I'm going to do first, give me feedback. If I lose you on a step, I'm not going to write everything out like I did on the previous one. That hasn't been my policy in this class. So I'm going to subtract the 4x from both sides. I'm going to get negative y is equal to negative 4x plus 6. Then I'm going to divide both sides here by the negative 1. Please don't forget when you do divide by something to distribute. So I have a negative 4 divided by negative 1, that's positive 4x. Positive 6 divided by negative 1 is negative 6. And there is that equation solved for y. So in the bottom equation, I am now going to take that y equals this junk right here, and I'm going to substitute it. So this is the actual substitution step. So I have 2x plus 5 times whatever the y value is equal to negative 8. I'm going to put in that y value of 4x minus 6. And now this is just a fairly routine linear equation to solve. So I have 2x, I'm going to distribute, I have 20x minus 30 is equal to negative 8. I'm going to collect my like terms. I'm also going to add the 30 over. So 2x plus 20x is 22x. When I add the 30 over, I get 22. And now when I divide both sides by 22, we get x is equal to 1. Any issues or problems? Again, I am 97.2% positive you've seen this before. So now I'm going to take that x equal to 1. I'm going to resubstitute it up here. So I have 4 times 1 minus 6. So that's 4 minus 6. The y value that goes along with it is negative 2. So if we were to graph those lines, that would be right there, the point of intersection between the two of them. Before I move on, anybody got anything that they need to have cleared up? All right, example 3. Now, like I said, for linear systems, personally, my preferred method to solve a linear system would be to just go ahead and do what's called elimination. And elimination, what we are going to do, the whole premise of this is we are going to eliminate one of the variables. So you tell me, for this problem, there's no right, no wrong answer to this next question. Do you want to eliminate the x's or the y's? Sure, thank you. Woo! I did not think that was going to be the most complicated question of the day. All right, let's eliminate the x's. You could have eliminated the y's. There's in this particular problem, there's no benefit to either one. Okay, so I have no mysteries. So the premise here to the elimination method is right now I've got a 3x and a 2x. If I was to add that together, that would make 5x. That doesn't help me. So what I'm going to do is I'm going to multiply both these equations by something to get opposite coefficients. So what's the common multiple between 3 and 2? 6. So what I'm going to do here is I'm going to multiply the top equation by 2, because 2 times 3 will give me 6. And then since I've done the top one by 2, I have to do the bottom one by negative 3, so that they'll be opposites. So questions right away are, hey, Perkster, could I have done the top one by negative 2? Indeed, you could have. The only thing you'd have to adjust is if you did the top one by negative 2, then you would do the bottom one by positive 3. Yes, so they'd be opposites. You might be looking ahead and say, hey, what if I had chosen the y's? What would we do there? Well, if we had chosen the y's, notice the coefficients on the y's are already opposites in sign. You would just need to make sure these numbers use a common multiple, like 12. So you'd multiply the top one by 3 and the bottom one by 4. Okay, again, does not make any difference. So now I'm going to go ahead and do this multiplication. So don't forget to distribute. So 2 times 3x in the top is 6x. 2 times negative 4 is negative 8y. And then 2 times 1 is 2. In the bottom equation, negative 3 times 2 is negative 6x. Negative 3 times 3 is negative 9y. And negative 3 times 12 is negative 36. And the lovely thing that happens for us is now when I smush these equations together, the x's are going to eliminate. So 6x and minus 6x, you notice those two things cancel. And then -8 plus -9 is -17y. And then 2 and -36 is -34. I divide and we get the y value is 2. There we go, we're half done. And then once again, it does not matter which equation you pick to figure out what the corresponding x value is. So again, in this problem, there is not any advantage to either of these equations. Neither one is simpler than the other. So I'm just going to use the top equation. So I'm just going to draw a little arrow from the top equation. And I'm going to substitute the y equals 2 into that. So I've got 3x minus 4 times y. So minus 4 times 2 is equal to 1. You would get the exact same x value if you used the bottom equation, because remember, we're finding the point of intersection, the point that is common to both of these lines. So here I have 3x minus 8 is equal to 1. I'm going to add the 8 over and then divide by 3, and I end up with x is equal to 3. So my ordered pair, my solution to this system is the x value is 3, the y value is 2, and whoop, put some squigglies around it. There we go. All right, I'm going to have you work through an elimination problem, but before I do you have a question for me? Any of that unfamiliar? Okay, then let's slide to the right. Let's all just do the same thing. Again, it doesn't matter, but just so our work all looks the same, do we want to eliminate the x's or the y's on this problem? Okay, I heard y first. Okay, this is math by whoever can answer fastest. So in exercise 3, if you want to do the same thing that I do, eliminate the y's. All right, I'm going to get started. If you're still working, keep working. We'll meet up at the end. I heard it declared that we are going to eliminate the y's. So what that means is I'm going to multiply the top equation by 4, because 4 times -3 will be -12. I'm going to multiply the bottom equation by 3. 3 times 4 is +12. Notice I'm not multiplying by a negative anything, because I've already got opposite signs on the y's. So when I do that, 4 times 2x is 8x. 4 times -3 is -12y, and 4 times -7 is -28. The bottom equation, 3 times 5 is 15x. 3 times 4 is what, positive 12y, and then 3 times 17 is, what's that, 51. Before I move on, does anyone have any different numbers that I have that we need to talk about? Okay, the rest of this, if you're being honest with me, the rest of this kind of just falls out nice and relaxed. So 8x and 15x, that's 23x. My y's cancel, which is what it was declared we wanted to do. And then negative 28 plus 51, I think that turns out to be 23. Going to divide both sides by 23, and we get x is equal to 1. Great. Again, there is no benefit to either of these two equations to resubstitute. So again, I'm just going to use the top. I have no secret reason for doing that. If you chose the bottom, we're going to end up with the same value for y. So when I do that, I've got 2 times 1 minus 3y is equal to negative 7. 2 times 1 is 2. Going to subtract the 2 from both sides and get negative 3y is negative 9, and then divide, and I get 3. So my solution is x is 1, y is 3, in some squigglies, so I don't confuse that for an interval. All right, I'm not hearing any questions. I'm seeing a lot of bored looks. It's all review, so just want to make sure, though, we feel pretty confident about this because I'm going to put a couple of these on the test. I want it to be free points. I want you to do great. So do exercise 4, and I'm just going to declare, I have no reason for picking this. Let's go ahead and eliminate the y's just for kicks. All right, so we're going to eliminate the y's on this problem. So that means what I'm going to do is in the top equation, I'm going to multiply that by 6. In the bottom one, I'm going to multiply by 7. And so when I multiply the top one by 6, 6 times 6x is 36x, 6 times 7 is 42y, and then 6 times negative 2 is negative 12. Bottom equation, 7 times 7 is 49x. 7 times negative 6 is negative 42y, and then 7 times 26, what is that, 182? Thank you for verifying that for me. My math is always sketchy first thing in the morning. So 36 and 49 turns out to be 85. The y's cancel, which is just what I wanted, and then negative 12 and 182 is 170. When we divide both sides by that 85, we get the x value 2. Now, I know we're getting whole numbers or integers as our answers, and that's just for ease of mathematics. Decimals are allowed. I mean, in fact, in any real world application of a system, you're going to end up with decimals, but we're just going through the process and learning how to do that here, reminding ourselves. Again, no reason to pick any of these equations. I'm going to use the bottom one just to be different. I don't want to be in a routine. So I'm going to take that x value of 2 and plug it in. So 7 times 2 minus 6 times y is 26. 7 times 2 is 14. Subtract the 14, and that is going to give me 12. Divide by the -6, and I have -2. So the solution here is 2 comma -2, and I'm going to put some squigglies around it. Still feeling okay? All right, well, I'm going to trust that if you weren't, you would let me know because there's no reason not to. Eliminate the x's in exercise 5, please. All right, so I'm going to eliminate the x's is what I recommended. And you notice we've already got a -6 on the bottom one. So if I multiply the top one by 2, that gives me +6. If you use another multiple, like if you just went with it and did the top one by 6 and the bottom one by 3 and put an 18 and a -18, it's all going to work out the same. Okay, so you got a lot of flexibility on this, but I'm just going to do the minimum amount of work because it's Monday and I'm feeling lazy. So 2 times 3 is 6x, 2 times -2 is -4y, 2 times 4 is 8. And then the bottom equation, Pen, what's wrong with you? Pen doesn't like it that it's Monday. Go to the pen graveyard. Okay, sorry to change colors on you. Hope this doesn't bother you too much. -6x plus 4y is equal to 7. That's the bottom equation. Now, here's the reason I gave this example, not just to torture you with another example, but what happens on the left side of this particular problem? Everything cancels. My x's cancel, my y's cancel, and so I'm left with 0 on the left. On the right, 8 and 7 is 15. Yeah, this is a false statement, right? 0 is not 15. I don't have to explain that, right? We'd rather have $15 than $0. Okay, so this is false. And what this is called when you solve a system and you end up with a false statement, this is called an inconsistent system. All the other systems that we've done, like over here, we got the solution 2, -2. This is called a consistent system. When you get a solution, it's called a consistent system. When you end up with a situation like this, what this means is that there's no x and y value together that would solve this, that there's nothing on both points. In fact, if you're trying to think of what does that look like as a picture, because we started this with pictures, these two lines here would be parallel. Okay. They have the same slope. They will never intersect with each other. And so there's no solution. And so the way we note no solution is we're just going to use our squigglies with nothing between it. Or if you like the null symbol better, use that, but pick your favorite. Don't use both. I've mentioned that before. Do the same thing with exercise 6. I'll give you less time this time. You probably already worked ahead because I think I gave you too much time on the previous one. Okay, so I didn't tell you whether to cancel the x or the y. It doesn't matter. We've got a similar thing's going to happen, but with a different conclusion. So I'm going to multiply the bottom equation by 2. I'm aiming to cancel the x's. So the top equation is 8x minus 2y is equal to -4. The bottom one is -8x plus 2y is equal to +4. This time when I add these two equations, not only does everything on the left cancel and end up with 0, but also everything on the right cancels and I get 0. So this time though, rather than getting a false statement, I get a statement that's true. 0 is equal to 0. It's a whole lot of nothing. And so what you get here is what's called a dependent system. And what it means to have a dependent system is that if we went back and graphed those two original lines, it's the same line. And so when you graphed them, they'd be one on top of the other. And so when it's one line on top of the other, what that means is it intersects at every point on the line. So the challenge in a dependent system is writing our answer. And so I'm just going to have us write the answer the way that this math book, there's a couple different ways that we could do this, but what our math book does is this. Okay, our math book says, okay, I'm going to write an ordered pair that represents this. So what I'm going to do is I'm going to say, okay, I'm going to pick an x value. And then what's the corresponding y value? Well, the way I get the corresponding y value is I'm going to solve this equation up here for y. So I'm picking the bottom equation because it's reduced. Notice the top equation, we've got 8, 2, 4, so I can reduce all those by a factor of 2. I'm just cluing you into this because when you go into my math lab, it's going to want the reduced equation. Okay, and I don't want you to accidentally get something wrong that you didn't get wrong. Okay, so I'm going to solve this bottom one for y just by adding the 4x over, so I get y is equal to 4x plus 2. And so what this says then is if I pick an x value on the line, whatever value I pick, then the y value that goes along with it is going to be 4x plus 2. And there is my ordered pair. That represents all the points on the line. So I can go ahead and pick any x value and then plug it in and get the y value that goes with it. And I have then found a solution because the solutions are any point on the line. All right, so that concludes our talking about linear systems. So now we're going to take the next step. Now, I think I misspoke earlier because I thought this was in the next section. It's been a while, so I forgot. This is probably something you haven't quite seen. We're going to now solve nonlinear systems. Systems that are composed of things, either one or both thing is not a line. For instance, in example 4, which I'm going to do with you, this top equation is a circle. We're going to learn more about circles when we come back on Wednesday. This is a circle and then a line. Now, if we're thinking about the picture of a circle and a line, I don't want to mess up my front here, so let me just go over on the back real quick. You don't have to do this. I'm just trying to give you a little illustration. I'm not saying that this circle and this line are what we have there, but I just want to show you the potential. If I have a circle and then a line goes through it, well, now it looks like I can have more than one solution to my system. I can have a solution there and there. Okay, so it is possible to get more than one solution in our nonlinear system. It's also possible to get just one. It's possible to get none. Just depends on what the graphs are that we're working with. For most nonlinear systems that we work with, substitution is going to be the easiest way to solve it. I do have one example on here to show you one, and the way it's set up that would be done by elimination, but you got to be careful when you're using elimination with nonlinear systems. Okay, so here we go. So what I'm going to do is I'm going to solve this by substitution. So again, I'm going to pick the easiest variable to solve for. The easiest variable to solve for is going to be this x right here. There's no division required. All I have to do is add that y over. So I'm going to add that y over, and so I get x is equal to y plus 2. Now, I don't want to lose anybody, so please let me know you following along so far. All right, well, here's the next step. It's just like what we did, and the whole reason I reminded you of substitution with linear systems is now I'm going to take that and I'm going to plug it in for x in the top equation. So in the top equation, I have x squared plus y squared is equal to 4. The x that I've got now is y plus 2, so I'm going to put the y plus 2 in, and I'm going to square it. Now, please, when you're doing this, don't forget to FOIL. I know we all would love it if y plus 2 squared was just y squared plus 4. If I could just square both those terms and be done, but I can't. So if you need to, I'll write this down. I'm not going to go through it. If you need to, just write down y plus 2 times y plus 2 and go ahead and do your FOILing. First outers, inners, lasts. And what you should get is y squared plus 4y plus 4. Plus another y squared equals 4. Well, good golly, I got myself a quadratic equation. So quadratic equation, I'm going to put everything on one side so it's equal to 0. Then you have your choice if this factors, which I think it does. So I'm going to factor, or you can use the quadratic formula. There's no wrong time to use the quadratic formula. So I'm going to bring this 4 over. At the same time, I'm going to collect like terms. So I've got y squared plus y squared is 2y squared plus 4y. When I bring the 4 over, when I subtract it, it cancels on both sides, so there's no more constant, so I just have equal to 0. I'm going to factor this. It has a common factor. I'm going to factor a 2y out of both of those, so I have 2y. And when I factor 2y out of 2y squared, I'm just left with y. When I factor 2y out of the 4y, I'm left with plus 2. And so I have two y values. My first y value is whatever makes 2y equal to 0. The second one is whatever makes y plus 2 0. So I get the y value 0 and the y value -2. And just like before, now I've got 2 points. Okay, I tried to illustrate that on my quick little drawing when I flipped over the page. I'm just going to take these now and I'm going to get the corresponding x value for each of them. So when I put y equal to 0 up here, the corresponding x value is 0 plus 2. So my first point is the x value 2 and the y value 0. The second point, when I put the y value -2 in, I get -2 plus 2. So that x value is going to be 0 and a y value of -2. Now it does matter, okay? My ordered pair represents each x and its corresponding y. You can't put the 2 with the -2. You can't just cross over, pick any x value, any y value. It's got to be the one that it goes with. And I'm going to put my squigglies around it because that's my solution set. I've got 2 answers to that problem. All right, so I've got one for you, exercise 7. It's another circle, it's another line so that you walk through the process. So go ahead, I'll give you 3 or 4 minutes to work through the arithmetic on that. All right, I'm going to get started. If you're working, keep working. We'll all end up in the same place. We're going to get two answers again because once again, this is a circle and a line. So first thing I'm going to do is I'm going to add that y over on the bottom one because the x is the absolute easiest thing to solve for. You might be saying, hey, Perkster, I solved for the y on this one. Am I going to be okay? Yes, you're going to be just fine. Your work's going to look different than mine, but we'll end up with the same two ordered pairs. No problem. Okay, so x is equal to y plus 1. So now in my top equation, I'm going to take x squared plus y squared is equal to 5. The x is y plus 1. Again, this y plus 1 squared, you have to FOIL, so don't get lazy on that one right there. So we've got y squared plus 2y plus 1 plus another y squared is equal to 5. Y squared plus y squared is 2y squared plus the 2y, and then I'm going to subtract the 5 over because I got a quadratic equation. When I subtract 5, I get a -4. Now you can factor that just as it is, or you can use the quadratic formula just as it is. What I'm going to do to make my life just a little bit easier is I'm going to factor out this 2 that's in common. That's going to make my unfoiling here a little bit easier. So when I factor out this 2, I've got y squared plus y minus 2. It's not a required step. You'll end up with the same two answers if you factored it the way it was. I just like to make my life a little easier when I'm able to. And so I'm going to forget that 2 because 2 is never going to be equal to 0. 2 is always going to be 2, so it doesn't affect my solution here. But what does affect my solution are the factoring of this. So the two factors of -2, they're going to add up to +1, are +2 minus 1. So I have then two solutions as I predicted for you. And my first one is going to be that y is equal to -2. And the second one, y is going to equal 1. So all that remains now is to take those two values. I'm going to go back to that equation that I solved for. I'm going to figure out the x's that go along with it. So for the y value -2, when I slide back up, I get x is equal to -2 plus 1. So the x is -1. So my first solution, my first ordered pair is going to be the x value -1 and the y value -2. The second solution, I'm going to take the y value 1 from down here at the bottom, and I'm going to go up to the top, and x is equal to 1 plus 1. So the x for that one is 2. So my second ordered pair is the x value 2, the y value 1. And here's my squigglies, and we are done with the problem. Questions, comments, concerns? Yes. There's no particular order. I mean, usually in sets we go in number order, but the problem here is now I've got an ordered pair and number order. Sometimes not on this one, you know, the -1 comes first, but sometimes in my ordered pairs, number order. You know, what if this was -1 and then +5? You know, so I'm not particular about the order of the solutions on these problems. Lovely question. Thank you for asking. Any others? All right, the last problem for this section then is just my instruction says to do this by substitution, but this one is also set up in the format that you could actually eliminate if you wanted to. So notice if I just add these two equations together, x squared and x squared is 2x squared. The y squareds cancel. Now this one is set up to be eliminated because both equations have the same terms, both an x squared and a y squared. Okay, elimination can get tricky for some of these if they don't have the same terms. So that's why I don't use it a lot. And then 8 plus 0 is 8. The other reason I have this example is this one, you're going to get a whole bunch of answers. It's a lovely problem. So when I divide both sides by 2 here, I get x squared is equal to 4. And then how do I solve this? What do I do to both sides to solve this one right here? square root. And thinking back in the past, we've talked about this before. When I impose a square root on a problem like I just did, I have to remember that what are my answers to this? Perfect. I have two. I have a positive and a negative 2. And the reason for that, I mentioned this before, but if I walk back up the ladder, if I start here at the bottom and I square both sides to get to the next step, which is working in reverse, then when I square positive 2, squaring positive 2 would give me the 4 I had, and then also squaring negative 2 would give me the 4 that I have. So that's why there's 2 answers. Okay, that's fantastic. I don't think that's anything too traumatic or cumbersome. So now I'm going to take each of these values and I'm going to go back up. I'm going to pick one of these problems. Now I do have a reason for in this one. I'm going to pick this one right here just because it's equal to 0. It's a little bit easier to work with than the other one. So I'm going to first take the x is positive 2 and I'm going to plug it in. So when I take the x is positive 2, I've got positive 2 squared minus y squared equals 0. So that's 4 minus y squared equals 0. I'm going to add the y over. I could factor this, but I'm going to add the y squared over and get 4 is equal to y squared. And then once again, like we just did a moment ago, I'm going to take the square root here. And then once again, just like a moment ago, we notice, oh, there's 2 answers to this. There is a plus and a minus 2. So all I plugged in is the positive 2 for x, and I got 2 y values out. So far what I have is I put in the positive 2 for x, and I got out a positive 2 for y. And then I put in the positive 2 for x, and I got out a negative 2 for y. But I can't forget that I have 2 x values. That's just for the positive 2. So now what I'm going to do is I'm going to go back to the starting line, and I'm going to do the same thing for the negative 2. So I'm going to do this on the left side because I've kind of boxed myself in. I wrote my answer a little too soon. So I'm going to take the negative 2, and I'm going to plug it into the same equation. So now I've got negative 2 squared minus y squared equals 0. And so that negative 2 squared, that becomes 4. So we're going through the same steps, but this time I started with the x value negative 2. I'm going to add the y squared over. And then once again, I am now taking the square root for the 3rd time on this problem. So if you forgot about the plus or minus, you're definitely remembering it now. And so when I plug in the x value negative 2, I get 2 y values. So this is a fun problem with 4 intersection points. That's great. So now with the x value negative 2, I get the y value positive 2. And also with the x value negative 2, I get the y value of negative 2. So good times. Lots of solutions there. I wanted to do that one just because of all the pluses and minuses. I know that looking at that can be a little bit daunting. Was there a question? Yeah. The top one is a circle. The bottom one is a hyperbola. Yeah, so you're on the right track. We're not going to talk about hyperbolas in this class. If you take pre-calculus, you'll talk about hyperbolas, you'll talk about ellipses. Those are great fun. All we're going to talk about in here is circles, and we'll do that next time. All right, any other questions before I shut down this section?